money. Also, I run this thing monthly that's called the Infrastructure Universe. If you haven't signed up for it already, you should. It just gives you monthly updates about new workflows, what are the latest updates or tools that have come out. We just had a release of all the 2020 stuff, so there's a lot of workflows in there. I also keep track of Civil 3D, what's new since 2006. So every new tool is in like a little matrix. And if you want the link to this, I'm going to send out a PDF with all these links later for everyone to look at. But you can basically go online and just type it in Google search and find it. It'll come up. I've been starting to put videos in there too as well. And probably if you're on here today and you want to know more, or maybe you're going to forget a specific workflow for a certain product, one of the point cloud things that I show you, on my YouTube channel, I actually have a playlist for point clouds, and everything that we're going to be talking about today is going to be in that playlist. So that way you can just go right there and look through the playlist, and you only have to look at that one product. You don't have to go through all of this information in order to find it. You can see I also make other playlists as well. I get a lot of questions on machine control and what's new in certain products and so on. So today's agenda. Today we're going to be talking briefly about what point clouds are and what they're made of. We'll talk about a few little important terms, and then we'll look at some different softwares and different ways to basically extract information from this. How are these useful or how are these not useful, and stuff like that. Any questions on the intro? All right, let's go to the point cloud basics. So just some of the terms that you should know, or hopefully we'll get to know, is there's basically the point cloud intensity. So point cloud intensity is a term that gets used a lot, and you can use it in Recap and AutoCAD to kind of see the intensity. And what that means is it's just the measured wavelength of when it hits a surface, how intense it was when it hit that surface. So it's just like how good of a hit was it compared to a lighter hit that was further away, and so on like that. And depending on if it's angled and all that kind of information. Another thing you should really understand is if it's laser versus Lidar versus photogrammetry. So Lidar is a laser based, but Lidar can also be terrestrial. I mean, it can be terrestrial and mobile at the same time. So it has different options for it. And the reason I bring that up is because when you're working in Recap or some of the other tools that have some auto extractions or like measuring pipes or grabbing center lines and stuff like that, some of the programs will not work with unstructured scans. And an unstructured scan is basically something that's created like for photogrammetry, so it doesn't have a real structure to it. So basically that's kind of, if you're not getting the tool, if it's not working for you in the scan, it's not because the program's broken, it's probably because of the scan information. So it's really good to know where the scan came from, what they used to create it, what kind of coordinates it's in, and just kind of ask that information. So here's kind of like my overall tips. So definitely know the data. You want to know, how it was created. If it's in a known coordinate system, that would be a good thing to know, especially if you want to line it up in Civil 3D. No matter what the program is, it's best to basically crop it. All the programs have different terms of cropping, sectioning, regioning. I'm going to show you some regioning real quickly in Recap today. But basically, it doesn't matter. Just break it up into smaller sections. Even though you can bring the whole thing into AutoCAD or Civil 3D, it's very difficult for the program to kind of handle that. If anyone's tried to bring them in before, they know what I'm talking about. Something to think about is a lot of people think they're going to be scanning these clouds and they're going to be saving all this time and all this stuff. And in a sense, you are saving some time. So you are saving time for collecting it. When you go out to the data, when you go out to a site or somewhere and you fly a drone, it takes about less than, 20 minutes to do a quick job, or you go and take a laser scanner and do a couple scans. I always tell everybody, think about measuring a room. And if I give you a tape measure in 10 minutes, how much information are you going to be able to write down on a piece of paper? And versus if I take 2 scans in the room. So basically, you want to make sure that so basically, you're going to be collecting the data, so you're not going to be saving it on necessarily drawing it. You still got to take that information back and trace on it. There are some automated tools, which we'll talk about a little bit, but mostly you're not going to, don't think of it as like there's a magic button and everything's going to be created for you off a point cloud. It's not going to happen. But it does save a lot more time, and it gives you so much more information than you're probably used to getting in a normal survey or as-build or something like that. You have to kind of think, in a sense, too, also with a point cloud when you're using it. You kind of have to be the surveyor in a sense, because you need to think of what's important to you as far as to grab what points where. Or you're the designer or the engineer. You need to figure out what do you need to base your design off of. That's what the points that you should be worried about grabbing on that point cloud. Don't try and think you need to model everything. It's just not that important. When you're doing surface terrains, it's a little different, but when you're trying to just grab like walls and windows and doors or curbs and ramps and stuff, you don't need every single point. All right, so those are important things you need to know. Let's just go over real basic what terrestrial scanning is. So we have some tips in some of the classes that we teach. We teach people how to basically go out and scan interiors. And just the kind of thing that I want you to know, say if you have a room or something, and here's the scanner, you'll notice that when it comes through walls and doors, you need to be able to basically link it back to itself. So when you link it to a new piece, what that's called a constraint. It's also called registration. So basically, you want to be able to put those two pieces together. How are they going to overlap each other? How are they going to relate to each other? So in this instance, scan number 1 and scan number 2, you have to have some kind of overlap for them. You can see where the shading of the red and the other colors are kind of overlapping each other. That's how they're kind of sharing the information. That's how auto registration happens. If you don't have anything that's recognizable by whatever program you're using to register, then it's not going to register together. So you have to have overlap. The more overlap you have, the better it is. Typically, it depends on your scanner, of course, as far as the distance-wise and stuff like that. But you can see in an area that's going inside, you can also see it also depends upon walls. So you can see on this instance, if somebody just did a scan here and a scan here, it has no idea how to constrain itself. Like it has no idea how to basically register itself together. All right. So if you're scanning a house or an object or something outside, you want to be able to basically set up here and then around all 4 corners of the building. So that way you have a full constraint. Don't think just because you get to this third one, you have enough of this area on both sides. You really should close it. This is called closure. So you should always, when you plan your scans, plan them in the area that you're going to be going through and basically putting some kind of closure to it. If you are interested in learning more about scanners and the different types available to you or getting demos and stuff like that, you can contact us. Bruce White is one of our main scanning guys. We may even have me come out there depending on the availability. Let's talk quickly about photogrammetry. Most people already know what this is. You know, basically a drone goes out. It does an automated process of capturing photos. It goes up to the cloud and then basically creates a 3D model for you. And then you can use this 3D model for a lot of information. Give me 1 second here. Sometimes the internet hangs up on me. Let me open Recap while this reloads. So in Recap here, I have a couple scans. This one's just an intersection. I have the color basically just showing different colors of scans. So there should be 4 different colors because we did 4 scans, 1 at each corner. But the thing I want you to notice is if you zoom in here, you get a lot of detail that's in here. I probably should slow down because this is on go to. So you can see you get a lot of detail in here. You can even get the divots, imperfections in the concrete. You got the curve face. And I'm going to show you later how to basically trace this inside of Civil 3D. These little shadows here are cars or people that are moving through the scan. That's called noise. And there are tools to clean up noise. And you can use Recap to do that too. See if my presentation loaded back up. You're on photogrammetry, I think. My colleague and I came up with this particular, in case anyone is interested in the different photogrammetry softwares. These are kind of the big ones. So Recap Photo comes with your AEC collection, I believe. No, I think the Pro you have to pay for. Then there's the Mapper for Pix4D. That's pretty common use. And then 3DR is more of an automated. And 3DR actually uses these two in the background to create it, but it's just a much more automated process for it. So we partner with 3DR, and I just want to go over just real briefly what kind of things that it allows you to do automatically. I'm not going to play every video in here, but at least we'll have some of them that we can basically walk through. This one's a drone that was flown in Arizona. They want to replace a bridge, and they use InfraWorks bridge modeler to kind of lay on top of it. They imported the point cloud into InfraWorks and then drew a bridge basically on top of it. The capture process is super easy. They have their own app. If anyone's never used an app for capture, you basically just draw a little area on the ground where you want to capture. Then you adjust the altitude and how refined you want your capture to be. And then basically it tells you how many batteries it's going to take and how many scans, and you just push run, and then basically starts and goes and does its own thing. This is one thing that's important for every project is ground control. You have to have at least 3 points of ground control in order to overlay your surface into a coordinate system. So hopefully you already have it. This 3DR makes a pretty nice process of capturing that. And then they've actually partnered with Trimble. They have this new little product that's actually pretty inexpensive, but basically you can go and get coordinate systems, just by hooking it up through this. So if you want more info on that, just let us know. It's pretty inexpensive. So you can basically get your own ground control now. Don't let the surveyors know that. Some other people are using this, especially 3DR for construction timelining, so they can kind of see how a project's timeline every time you go fly it every month, and then they can kind of look through and see the difference between what's happening on the job site. They're using it for the construction QA/QC as well, because they're using it to overlay the CAD files and make sure things are lining up where they're supposed to. So is the pipe going where it's supposed to? Is the outer building where it's supposed to? Is this column where it's supposed to be? So basically you can upload CAD files into 3DR and kind of overlay them to make sure things are going where they're supposed to. They have a thermal inspection option, but other things you can get with 3DR is it's pretty standard, like for any of these products here, is you can pretty much just get them to give you your contours for your surface to use in Civil 3D. And I think we even went over that inside of here as far as what the output is, and contour lines, 3D mesh, ortho, mosaics. If anyone's not sure what the term ortho mosaic is, it's just basically like the same thing as your satellite imagery. And so basically that is a high-res imagery that you can use in your background for Civil 3D or whatever product that you want, InfraWorks. If you want to discuss more these options and do it on your own, or have us train you, or do whatever, you can just contact us at info@uscad.com. We have a full staff that has skills and technology of all this stuff, so we can go through that. Let's get to the meat of the presentation. So let's talk quickly about Recap. I'm sure people have probably at least opened it, if anything, like I just showed you a moment ago. And then they always ask, well, why do I got to use Recap? Well, a few years ago, Autodesk made the Recap kind of like the standard. And it kind of made a little sense because of the fact that I remember in Civil 3D, we could take in different file types and create surfaces out of them or whatever. But imagine all of the products. So in the AEC collection, there's what, 27 or plus products. Imagine if every one of those programs, departments had to write a way to import all the various types of formats of point clouds. That would just be a mess of programming. So they made the smart move, and they did make one program that basically imports all the various types of point clouds, and then it converts it into an Autodesk version of a point cloud, which is an RCP or an RCS, either a project file or a scan. So the scans are just each little scan, and then the RCP is a bunch of these little RCSs. But basically, then you can go into any of the Autodesk products, and you can open up that RCP. So now these program engineers can focus on writing codes for other things instead of having to go and keep updating the codes for scans. So that's kind of why they do it. I always like to talk about too, and maybe if Autodesk down here, they should probably cover their ears for a minute, but there are some limitations with recap. So one of the things I really don't like is the fact that it's in meters. So everything's in meters. Even if you have ground control or coordinate system, it has to be converted to meters in order for you to specify that in when you're doing registration. There's also, I've had some issues with sometimes the coordinate system just doesn't work for me, and I don't know, there's just some glitches with those. Mainly what I use recap for is just kind of opening up a point cloud and putting some regions in it and then saving it and then using it in another product. So I'm not really using recap a lot to do a lot of other things. So I just wanted you to be aware of those. Some of the tools that it has, and one of the ones that we'll talk about for sure, is the ones for clipping and making a region. It also does distance and angles and markups, and it has a little preview of a scan to mesh, but it's got like a 30-meter cube limitation, so you can't go bigger than that. There's project cleanup tools. The other great thing about Recap too is it's also the only free software you can basically share the point cloud to anybody else. So that's really nice about that. And you can even publish it online and they can view your point clouds through the web browser. So that is one great thing about Recap as well. These are the step-by-step instructions, but I'm just going to jump in the program and show you. I'm not actually going to make you sit through that. But one of the main things I usually do here is, let me just back out a little bit. Just kind of orient my view here. Oops. And then what I do down here is there's a little window option, and I'm going to use this thing called the fence tool. And I'm just going to segment out just this curb and gutter on the side. And to end or close the fence, you just double click, and then that will shade that area. Then you can come to this button down here at the bottom. A lot of people do clip inside and outside, means you can clip, but we want to be able to do a region. So I'm going to say, let's do a region, and I would say, let's do a new region. And then this would be my north, I think that's my northeast corner. And I'll just hit OK. Now, why would I do that? And I keep doing it on the other ones is because when I come over here to this little layer options, I can expand this thing where it says scan locations. And then it has a little one that says unassigned points. Those are the points that we did not grab in any box. So I'm going to turn those off. And you can see now I have each one of these little sectioned areas. You can also come in here too, if like that noise that was in here. Oops. So some of that noise that was there. You can basically kind of maneuver around until you get to an area that's cropped. And I can also use that fence tool again. And then I could say delete those points, and then it'll basically clean it up. But that's quite a manual process, and I usually don't do that unless I really, really have to. From this point, all you would do is just save the file, and then you have your RCP. One other little note I want to make in here is people get this little coordinate thing confused here. So when you set up this project units, it doesn't actually convert the recap file. It's still in meters no matter what. Even if you take it into a Civil 3D or AutoCAD file, it's still coming in as meters. It will convert to the units, that's the drawing. This right here is only meaning when you measure, it's going to show you in the units that you want to see the measurement in, but it doesn't actually convert anything. So I used to think it converted things, and I was sadly mistaken. All right, so let's back out of here. Let's go into AutoCAD. So AutoCAD has its own special tools that it came out with. Some of the notable ones are the ability to crop, which you could. The problem with that is if you take the whole point cloud in and then start cropping, the AutoCAD is kind of slow. So I usually like to point out, like here, no matter if you're in any AutoCAD-based program, Civil 3D is an AutoCAD-based program, the speed of larger point clouds will slow down AutoCAD. AutoCAD was not built to do demand rendering or demand loading. AutoCAD will render everything that's in the drawing. That's why when you have drawings that have multiple tabs or tons of text, how they just start to run slower and slower and slower. Even though you're not looking at that information, AutoCAD is rendering that in the background. So the program really wasn't built for this type of large files. So that's why I say in recap, it's just easier. You saw how quickly I could just make a quick region out of that. So that's probably the best thing. I'm going to show you this tool that basically we're going to do a section, and then we're going to extract the 2D geometry from a section view. This is the step-by-step process, but I'm not going to bore you with these little slides here. And like I said, there's also YouTube videos to this a little later. So I'm just going to show you AutoCAD. So I've already inserted a point cloud. If you want to know how to insert, you just go, or point cloud, you can just go to the home ribbon. Actually, you can just type XREF, surprisingly. And up here at the top, you'll notice you can just take point cloud. That's usually the way I go, but there isn't a place on the ribbon. I'm just never familiar with where it's at. Once you have the point cloud in, you can see that it automatically turns the visual style to conceptual. So if you try to do like wireframe, it's just going to say it can't be displayed in 2D. So you have to be able to have it in some kind of rendered format. So this is just a basic room here. Let me just rotate and side view. I just wanted to make it super simple. What you can do to edit a point cloud or get the tools is you just kind of click on a point cloud and it brings up a context ribbon. You can do things like adjust the point size, and that's not really that important. This one you can change the color intensity or the mapping, how things are rendered. But one of the most important ones here is this one. So this point cloud manager, I use this one a lot. And the reason why is you'll see the regions. You'll see the other ones when I get into Civil 3D for the ramps, but you can see I put one in here for ceiling because I basically took the ceiling off and recapped. So you can make regions dependent upon what you want. And then you can turn them off and turn them on with this little guy much quicker than you can go and try and section it out. While you have this selected though, or while I have this selected, basically I'm going to use a thing called a section plane, and I'm going to do a top section. And then you have to hit escape, which is really strange. And then you have to select the line here. And what I can do is, it's a live section, but I want to change it to be a slice. And basically it pulls up a slice of your floor plan. You can adjust where that slice is being taken, higher or lower, and then you can also adjust the thickness of the slice as well, just by clicking on those little numbers. But probably the most interesting or funnest part of AutoCAD, and you can see the inside of the walls here, just based upon that. But you can use this tool that's called generate or extract section lines. And then you have to select the point cloud, which it makes it very difficult to do sometimes. Right there. Then you get this little box. It says extract the lines for the point cloud, so you can tell it what layer to put these lines on, 2D, and then what your polyline width is going to be. And then you can also have these tolerances here on how you want it to extract. You can play with these a little bit. I find putting the numbers down within like half an inch is probably a little better. And then you can basically also pump this up for points to process, but usually fast is best. I want to see if I'll just run this and see what happens. Sometimes it just doesn't run so quickly, so if it gets too much, I'll push it over. All right, so this is one that already extracted. You can see basically it'll extract the top of your section. So basically just cut a line around the top of my section view, wherever it is. But let's talk about one more thing here. So I'm going to delete this section view out of here. And there are some other tools inside of AutoCAD that are interesting if you're just doing it. So this is where I said you really have to be manual and you really are kind of tracing or drawing on top of things. If you don't have your 3D snaps on, you have to go down to this little hamburger button and say 3D object snap, turn it on. And that's this little guy right here. And then there's object snap settings. And most people are used to the 2D ones, but they didn't know there was even a 3D object snap, most people. And they didn't even know that there is a point cloud one. There's the ones I use mostly are node, mostly in Civil 3D, but I'm going to uncheck that one. Because if I have this one checked, it will override these ones. And I want to do the edge or a corner, and then perpendicular to edge. And then all you can do is just start like a line command or polyline, and you can see how I'm hovering over the point here, and it says nearest edge to point cloud. And then basically I can pull in the point cloud itself and draw on top of whatever I want to do. So that's kind of like how the point cloud tools work in AutoCAD. There's not a lot to them. Basically, you're going to be tracing on top of each other. But that's pretty much the basis of AutoCAD itself. Any questions on that one? All right, let's go into InfraWorks now. So in InfraWorks, why am I using this? I'll tell you in a second. This is where they started putting a lot of the point cloud tools, the newer ones that they're writing. You can start by setting up a project. If you're not sure with how to do that, we do have step-by-step instructions for that. So that's one way to do it. Some of the tools that it has, though, is it has the Generate Terrain tool, which is the one we're going to be talking a little more extensive about. And then there is the basic feature extraction ones, which we'll kind of cover what those are too as well. There's some basic instructions down here on how to import a point cloud. It's pretty simple, but in case you need them. This is the point cloud process. So one of the questions I get a lot, which I'm going to cover first, is why use InfraWorks to make a 3D model or a terrain model versus just using the Civil 3D tool? Well, I like more control. So if you go in Civil 3D, what you're getting is you get three options on the filter method. You get planar average, you get the curing interpolation, or you get no filter. In InfraWorks, you have, they define them a little differently. It's called more detail, aggressive, more features, optimum, less, passive, and then you have custom, where you can come in and basically tell it things like, what's my max curve height, what's my minimum curve height, what's my feature resolution going to be, fill in the terrain holes, what I want my grid at. I mean, you have all these options inside of InfraWorks that can basically kind of deal with the surface that you don't have in Civil 3D. So that's why I usually process my terrain. I will use InfraWorks. You could just get it from, if you're using Pix4D, just process it out of there as well, but you could just use contours if you wanted to. So what the terminology means is basically there's like ground details. So that's basically like the grid size. So how dense do you want this grid? You don't want to pump it up pretty high, especially if it's a large project, because Civil 3D will never be able to open the thing. We've all seen surfaces that are really, really big. So you got to kind of play with the numbers until you get it is what you want. But all these little features talk about what it is. So the ground classifications, and then the linear features and what that means. So linear features just means things like curbs or retaining walls and stuff like that, which basically go along some kind of straight corridor or something like that. Then there's something else called vertical feature. And I'm going to talk a little more detail about linear features and vertical features after we talk about the terrain process itself. This is the basic point cloud inside of InfraWorks. This is what it looks like. I have to show you guys a video and pictures of these because it would take too long to process this stuff. So basically what I did is I went through and I processed with just the optimum processing. And the only thing I really was noticing that I could see visually changing on the screen was this mound right here, and that's why I put a little arrow. So each time you can see the mound is a little different depending on which features I tell it to take. The custom one is probably the most accurate out of all of them. So basically that's kind of the settings and what the difference is between them. Once you have that surface terrain, so here it is in InfraWorks, you have your contours, and you can basically take this into Civil 3D. So you can basically save it. It saves it out as a recap file. So then you can just bring that in. Actually, you don't even need to do that. You can just, I'll show you in a second what you can do. But InfraWorks, the process terrain, so this is what it looks like. These were my process rules that I got, and this is what the surface statistics ended up looking like at the end. So actually, it's not too bad. If you're trying to get curb, like major curb work from photogrammetry, it's going to be very difficult. It's not easy to get that kind of detail out of photogrammetry quite yet. So some of the other point cloud tools that InfraWorks has that's really cool is the one that's called feature extraction. So the ability to basically take any type of object like a tree or a light pole or something of that nature and then have it automatically extract it for us is pretty amazing. So what it does is basically can take a point cloud here and it will automatically extract data that it knows is vertical. So it knows that things are shooting up out of something like a light pole or a tree, and then it can kind of make recommendations and automatically replace it. So sometimes it does good at replacing them, and then other times it just gives you a bunch of yellow boxes that you got to replace with something. But it takes it out of the terrain surface. So at least it gives us the best terrain surface that is already there. But this is definitely the next level of where things are going, and there's probably every point cloud type of software company like Leica and Faro and all the others. They're all in this race together to try and see who can get the fastest and best one there. There's also this other portion that I want to talk about. This is called the linear feature extraction. So this will extract feature lines or break lines into Civil 3D for you. You can go through the different sections and move around the flow lines and stuff and basically get the feature line and linear information and take it over to Civil 3D. So from there, you can basically just open it up and you have your feature lines, you have your surface, and you have everything ready to go. This just talks more about customizing the actual break line portion of it, which we kind of showed in that video, but it shows more detail. So how to transfer from Civil 3D to basically InfraWorks. It's pretty simple. They actually integrated a tool inside of AutoCAD or Civil 3D. It's actually on the insert ribbon. It's called InfraWorks. However, the little caveat here is in order to import a InfraWorks, like a current InfraWorks model, like the SQLite files, you have to be in the most recent version of InfraWorks and the most recent version of Civil 3D. So like now that 2020 is out, you have to be on 2020 in order to be able to bring in the SQLite. Otherwise, you're going to have to manually go through and extract the file as an INX file, and then you can bring it in to an older version. I usually just have, well, I always have the newer versions, but somebody in your office should hopefully just have the newer version around just to do this, so that makes it super easy, and then you can just always make sure they're not using it for production. I hope. From there, there's just the instructions on how it comes in. So when you bring in that file here, it's going to ask for the coordinate systems, and then what I'm looking for is a terrain. So it basically merges once you process the terrain in InfraWorks, it merges it into the existing surface of InfraWorks. So this is the main one that I'm looking for. The other data that comes through with InfraWorks itself, so we have the terrain surfaces, the one that we're looking for the terrain, but I don't know if a lot of people are aware of the fact that it will basically bring in all of your alignments for the center line alignments, your existing topography, and then if you did component roads in intersections, it will automatically bring those over as corridors. But again, the caveat is it has to be on the same, you have to use the SQLite, and you have to be on the same version. So you could open it in 2020 and then just save it down to 2019. It'll work because nothing's changed in those tools from there. This is the results of bringing it over into Civil 3D once it's done. And I can open up that file here too. I think I have it. Civil 3D, got too many things open. So this is what I brought in from InfraWorks itself, just so you can kind of see what's going on here. It's probably going to ask me if I want to turn on the satellite imagery. Nope, I already did. But here's the surface that it brought in. And then here's the alignments that it brought in from the GIS data from InfraWorks. It automatically names the roads or whatever they are. So even just getting this information just from InfraWorks without even doing anything else in InfraWorks is pretty amazing. Any questions on that? All right, let's get into what if you have to model in Civil 3D. So Civil 3D, you basically have all of the AutoCAD tools that we talked about a moment ago. So you have all those. Then if we want to do something like, in this case, I want to model this curb ramp. And I did the full YouTube video, so I'm not going to actually model the whole thing in front of you. I just might do a piece, like one little line. But pretty much I talk about here how you basically want to do those regions and region it out to make it easier. Then when you bring in the point cloud, you want to be able to turn off the regions except for the one you're going to be working on. You want to make sure to have your snapping tools on, and we're going to use the node one this time. And then we're basically going to just draw a feature line on top. We'll draw feature lines, and I'll also show you how to draw points too. They're pretty much similar, but they both use that node tool. And yeah, there is a video if you guys want to watch it later. You can do that. But let me just go back to Civil 3D. Oh, that's the finished one. So let's see. I'm going to bring in the point cloud here, and I'm going to go to attach. Let's bring in this guy. The nice thing about point clouds is it has the zoom to point cloud. I wish they would do this with the XREF manager. So it automatically zooms into that. And then let me just rotate my view here. I'm going to get on this side. One thing I am going to do, since this one doesn't have any color, it's kind of hard to see. I have a white background, but I'm going to change the color transparency here to be a little lighter, so I can just lighten it up a little, so I can see a little better. All right, and then now I'm going to go to that point cloud manager, and basically I'm going to turn off all of them except for that northeast corner, because I don't need all that information slowing me down. So here I have my little sections, and if I want to start, I'll start with points first. So let's just do a point because that's pretty simple. You just go to the point tool, you go to the point creation tools, and I will go, the thing you want to make sure is set is the prompt for elevation should be set to manual. As long as that's set, then you're good to go. I'm getting this weird little rendering thing. There we go. So I'm going to go to manual, create, and then you can see the node is automatically snapping to all the little points. And here's the thing where I was talking about earlier, like you just got to figure out what is going to be the best point for you. Unfortunately, in this program, there's no way to say, you know, on the closest point, what is the highest point or something. Like over here, it'd be nice if it would kind of let us do the high point. Actually, let me try using the, turning off the, let's turn off this one and leave the edges on and see if it'll let me do it that way. I know it does it for points, but sometimes it doesn't do it for the faces. Yeah, see how yeah, I don't know if I'd trust that though. Yeah, it might be okay. It's going to ask for a description, and then it's going to prompt you for the elevation of what it is. This point cloud is not in a reference system right now, so it really doesn't have any real world value, but it's going to pull whatever the point value is. So that particular point from the point cloud is at -7 feet. Then you just hit enter to accept. You do the same thing for the feature lines though. So you go to create feature line command, and one thing I'm going to do here is I usually like to adjust my line weights, which a lot of people hate. I'm going to adjust it. And then what I'm going to do is basically you just start picking on the points that you want. So I'm going to turn my node thing back on. Confirm the elevation, and then go to the next point. And then right now, it's just like the feature line command. So basically, you're just tracing on top is all you're going to do. And then from here, if I want to do an arc, I'm going to do a second point. And you'll definitely figure out that you're probably going to have to do a couple arcs because of the fact that nothing in the real world is really tangent like we design it to be. So you might have to do a couple arcs to get things to go where you want them to. But you just got to kind of pick the points that you feel are going to be the best points for your design and what you're trying to get information out of. And then that's where you can basically get your curve information. I know it's a very manual process. We'd like a little magic button that would automatically do that for us. I'm even going to show you something that might do that similarly on Leica, but it doesn't really work for curves mostly. But the reason why I use line weight tools is so that way I can see what I've done and I can turn it on. But pretty much that's all you can do with Civil 3D is just trace on top of it. Some people asked me the other day about Navisworks. It does have some point cloud tools. The main thing though is basically it runs clash detection. They wanted to be able to run a clash between a point cloud and see if it was something else like a wall or building were lining up with it or clashing with it. So basically they just asked if I could do this real quick, and sure can. you guys want these files too, I can give you the files as well. But basically, this will set up basically the collision between the two different types. The only thing that it does is it will automatically make things called voxels. Voxel is just kind of like an area of a point cloud, and there's no way you can specify what is a voxel. It's just that is what Navisworks makes. But ultimately, you can run the clash detection and get your test results, and then see what's colliding with what, and go through the clash list. There's also step-by-step instructions here as well that are right here if you want to do that later. A little caveats with, let's see. Yes, you will be getting a copy of the presentation for sure. You'll be getting a copy of this, the Prezi. I'll send you a link. You can also download this link. And I'm going to send you a PDF version of these instructions, which is a little easier, so you don't have to click around in here. And all the links will be active in there too. So yes, you will be getting that information. Let's talk about Leica. So Leica has some pretty amazing software as well that we use a lot. There is one product called Cyclone, and there's another one called CloudWorx, and then there's another one called 3D Shaper. So let's talk a little bit about what Cyclone is. This first cloud is just explaining the step-by-step process on how to set up a project in Cyclone. So we're not going to go through that. But some of the things I really like to look at is, some people ask me, well, I remember I was talking about the noise and cleaning it up a little earlier. So this process will allow you to basically clean up vertical noise. This was a street that we were doing, highway, I think, and you can't ever make cars stop, so there was a lot of noise in it, but basically we can use a cleanup tool to create it, and then we can create a mesh and push it out to Civil 3D. Somebody asked me, can you do points on a grid? Yeah, you can easily generate inside of this program, do Kogo points on a grid. But the one that I love the most is this one right here. And this is the ability to basically create curved lines. So you can make an alignment inside of this program as well, and the alignment will transfer over as line XML, which will transfer to Civil 3D. But on this alignment, you can basically go through a sectioning tool, and we can start creating little sections for it. So you just kind of draw where it is. And the other thing I love about Leica in this program is when you pick the point, it will automatically pick either the lowest or highest point depending on your settings. So you don't have to worry about clicking on the wrong points. Even if you're in plan view and you're over trees and you click, it will go to the lowest point if you have the settings set to the lowest point. So that's why I kind of like these programs a little better, because you have more controls over what you're doing. But in this instance, we're basically making an alignment from this flow line that we have here. And then we're going to go through and make some sections out of it. So we're basically going to flip into the section view and say create. And then if the sections aren't lining up, you know how kind of the flow lines, of course, deviate depending on the next section. But right here, what we can do is we can say which points are going to be important to us to draw line work. So how do we want it to basically build this out? And we can basically say, let's build in a back of curve, a flow line, or a top of curve, a flow line, and then an EC. And then we just kind of drag it close to where the points are in this view. And then we'll go to the next section and do the same thing. So it's similar to the way that InfraWorks did it, except for this one's a little easier to work with, I think. In the end, what you end up getting is you basically end up getting a cross-section view. Well, you can put Kogo points on those points as well. And then when we rotate into a 3D view, what we get is actual what we'd want. I mean, this is as close to the magic button as you're going to get for now. But basically, this is the process. If you want to learn how to do this, I can definitely teach you how to do that. And the video's there too, so you can just watch the video. I probably won't go too much detail into this. There's also videos on this, but there is tools to automatically extract pipes. So in the point cloud, you can see that there's some pipes here, and then we can just say fit to cloud. And what that means is it'll basically go in and it will look at a catalog. So we can specify some kind of catalog that we're looking for, and it'll fit the pipes that fit within those tolerances. So it knows the best pipes that it can do, and then you can replace with fittings. and then you can basically push it over into AutoCAD or Revit or whatever product that you want to be able to use the 3D pipes in. This one's also another product that works inside of AutoCAD or Civil 3D or Revit, and it's called CloudWorx. It basically links to a Cyclone file, but you actually get to work inside of the program that you're in. So if I'm working in, say, Revit, I can basically have my own, it has its own ribbon, and you can basically have your own tools in here and extract pipes and stuff like that too. So it's pretty nice that these point cloud tools are kind of awesome to have added. So having CloudWorx, I didn't show you guys that, but having CloudWorx on AutoCAD or Civil 3D really does help. So you can do a lot of information with that. There's something I ran into the other day. Somebody asked me how to create families. So they can actually, there's a video out there from Leica provided that they show how to create like a doorway family based upon a point cloud. So that was pretty awesome. And then I discovered this a little while ago, and I kind of really like this. At first, I didn't understand the relationship, and I still kind of don't understand. So there's Leica Geosystems, which is related to Hexagon Geosystems, but I don't know who's in charge of who, and they don't know who's in charge of who either. But basically, this product here, this 3D reshaper, is part of the Leica family. When you search their website, it's on there. But some of the things that it does is, it will classify the walls and doors. So remember we talked about classification. It will do that. It has this really cool feature where it will basically unroll. They call it unrolling a polyline, but basically it's putting a line down your alignment, so like a 2D or 3D line, and then you can create a quick profile in the program. It has this really awesome tunneling tool, which will basically create a tunnel out of your scans if you have the scan data. It has this other tool here, which is really nice because I get asked a lot, how do you compare point clouds? So over time, if you scan a cloud and then you go and scan it again, this program will allow you to basically look at the difference between the two. And then it'll generate reports into a PDF, and you can see basically the deviations of this dam over time on this one, where things have either sagged or moved or something like that. It creates volumes, but I mean, we have Civil 3D and to do that. It also will do sections off of a point cloud, which is really nice. But another one I really thought was cool was this, the ability to kind of like use filters, and it will separate out according to the real color of the scan. So if I want to remove things like grass and pavement and have everything classified into different types of materials, this is kind of an awesome, really awesome tool for that. So there's also a video here as well, if you guys want to watch it a little later. So basically you can come in here and watch some of the tools that it has as far as the reporting methods that it has. You can customize your own templates and a lot of the new little features that it has. It's a pretty awesome program. I recommend taking a look at it for sure. Oh, another big thing that this thing does is I get asked a lot, this is mostly by architects or visual rendering people, is creating a mesh out of your either photogrammetry or whatever your point cloud is, because they want to be able to use it in like 3D Max, or they want to render it in some kind of AR or VR environment, or just make renderings. This 3D reshaper basically turns things into meshes. So to basically turn your point cloud into a mesh. Recap doesn't do that currently at this point. Meshes are pretty nice. Any questions on Leica? I did list, I'm not going to go through this, but I did list some tools or workflows for 3D Max and how to basically model if you get into that. There's also some videos there as well. But like I said, 3D Shaper is probably a better program to make a mesh out of. Unless you're just trying to model the objects, you can do that. And then I've even been asked for Inventor instructions on how to import point clouds into Inventor. So you can basically use Inventor to model objects off of. So everybody in every industry is using these. One way or another, they're basically using some types of point clouds. And then my bosses probably wouldn't like me to talk about this one. I do have a relationship kind of with these guys. But basically, this is called Edgewise, or clear edge. They do have one that will kind of automatically find walls that you can use in Revit for extruding. They also have ones for windows and door extrusion. And they also have steel and piping ones as well. So similar to the Leica ones. Like I said, there's so many different products out there right now. It's like an arms race for point clouds because everyone's trying to find that magic button. Hopefully this was beneficial to you and you know a lot more about point clouds and what you can do with them. Basically, if you're using the Autodesk workflows, you're tracing on top of things. If you're going to get into additional software where you see yourself using a lot more point clouds, then I would definitely upgrade to something else as far as like Leica or something like that to get your workflows a little faster. If you have any questions on any of this stuff, any of the BIM information, any of the point clouds, modeling, whatever you guys need, definitely hit us up on our email there. And then next month, I believe the Infrastructure Tuesday is going to be a Bluebeam tips and tricks one. So you might want to sign up for that one once the link gets posted. And you will have this available later, so you can watch this, listen to me as much as you want, or you can ignore me and just get the class links to the PDF and the other videos. And I should show you the playlist here. So like I said, if you haven't signed up already to my YouTube, you should, because of the fact that I do have the playlist here. So here's the point cloud one. But basically, I have all of the different point clouds. Some of the videos are from me, and some of the videos are from other places like Autodesk or CAD Learning, who we partner with as well. So I try and collect as much from various sources and not have to remake it if I don't have to. So, but there's a whole list of 31 videos in here. So you have a full list to keep yourself busy looking at those. Well, I hope that was beneficial to you, and I will, well, let me open up to questions, see if anybody has questions, and then if not, we'll close it out.